Hello everybody and welcome to the homework helper for section 4.1. Let's go ahead and go over everything and we'll go from there, of course. The very first thing that we're looking at is we're trying to recall transformations on quadratic functions. So to be able to do that, it's useful to think about what those transformations are. And it talks about vertex form. So it's good to know exactly what vertex form is because vertex form tells us what those transformations are going to be. So this here is vertex form. Boom. Should probably put a little y equals in there. Y equals a times x minus h squared plus k. Where hk is our vertex, here's our hk right there, and a is our stretch. A is our stretch. The bigger the number, the narrower it is. If it's a fractional number, it'll become wider. So when looking at number 1 here, we need to figure out what this transformation is doing, what exactly is going on with it. So when I'm looking at this, I see that it deviates from a normal parabola, just a y equals x squared parabola, by being pushed down by 1, 2, 3, 4, 5, 6 units, as this is the 0.06. So when I'm looking at it in that terms, I know it's going down 6 units. But then I'm also thinking about what is that stretch value? Is there a stretch value? And so when I'm looking at this, I'm expecting a normal parabola to behave by going like so. I'll do a quick little sketch. 0, 0, because 0 squared is 0. 1, 1, because 1 squared is 1. And then 2, 4, because 2 squared is 4. And then likewise, negative 1, 1, because negative 1 squared is 1. And then negative 2, 4, because negative 2 squared is 4. Negative 2, 4. So it should look like this. And my little cheater method for thinking about this, or cheater method, one of the shortcuts I make, one of the connections I've made to use mathematical language, you know, one of the patterns of regularity and structure that I see when I do this is, let me zoom in just a little bit on the old dot cam, is we go over 1, up 1, over 2, up 4. So what I'm looking for here is I'm looking to see if that happens. I go over 1, up 1, yeah. I go over 2, up 4, yeah. So that's our base parent graph translation, or stretch, I should say, which means our a is 1. So that means our equation is, if it's y equals a x minus h squared plus k, well, my a is 1. My h, my left and right transformation, is 0, but my k is minus 6. It's minus 6. I wrote 6 for some reason. So my equation is y equals x squared minus 6. And I'm just looking for that in all of these. You know, when I look at the number 2 here, yeah, there's a vertical translation down, so it goes down by 5. But it also stretches. And when we're thinking about what that stretch can be, we need to look at what the pattern is. So again, normally I expect 1 to 1 and 2 to 4, but this time it's going 1 to 2 and 2 to 8. So the stretch is double what I would expect it to be, so my stretch should be 2, double. So my equation would be y equals 2x squared minus 5. And then we'll just apply that for all of them as we go. Looking at number 4 real fast, we see that it's a frowny face. So that means our a is going to be negative. Okay, our stretch is a negative as it flips. Okay. Let's go ahead and go to the next page, the set. So the set is going to be exploring a rational function. And for this one, I highly recommend that you just go through it step by step. Okay. It's going to lead you there. You know, we start with you know, Chile is celebrating her quinceañera. Hannah knows the perfect gift, but it costs $360. She can't afford to pay for it on her own, so she's thinking about asking friends to join her. Okay, so we're going to be having different people have a share. So how much would each person spend if there were 2 people dividing the cost of the gift? So if you and I were buying the gift for her, we would each have to pay half of $360. Okay, half of $360, or we'd have to pay, what is that, $180 a piece? If there were 5 people, what would that be? Well, that would be 360 divided by 5, which would be $72. 360. Here, I'm cheating. I'm using a calculator. Divided by 5. Yeah, 72. Look at me knowing what I'm doing. Okay, and so it's going to ask you to go through this one step at a time. 10 people, would be $36. 100 people would be $3.60, et cetera, et cetera. Let's put some dollar signs on there so we know we're talking about money. Okay, and so it's going to ask you further how all of this is changing, and it'll ask you to graph it from there. But just follow the process, do one step at a time, and it'll guide you where you need to go. Finally, the go section. Ooh, negative exponents. Why did I write that note? Well, we'll find out. So here it's asking us to review exponential functions. And it wants us to match them and then write the equation of the horizontal asymptote. So let's start with the basic one, which happens to be number 11. It's just f of x equals 2 to the x. Now, there's a couple of different ways to think about this. The way my brain works is I start thinking about it in terms of a table. So when I think about this, let me make sure it's on the screen, is I think about what x could be, and then I think about what my output is. So at 0, 2 to the 0 power, well, anything to the 0 power is 1. Oops, let me screw that over just a little bit more. 2 to the first power is 2. 2 to the second power is 2 times 2 is 4. 2 to the third power is 8. Now, I also want to think about numbers on the other side of my y-axis. So when x is -1, what happens? Well, that's 2 to the -1 power. Well, 2 to the -1, that inverts it, right? Let me do a quick little sketch. 2 to the -1 is the same as 1 over 2. That's a half. Okay. What about to the -2 power? Well, 2 to the -2 power, well, that's 1 over 2 squared, which is a fourth, 0.25. So that's my basic function. And when I'm thinking about this and when I'm doing like a matching problem, I just pick a point and try to find the point that works. And where x is 0 is a real easy point for me to kind of wrap my head around, because that's just the y-axis here. So here it's, what does that look like? 4? No, it's not 1. Here it's 1. Okay, so this one might be it. Oh wait, no, it's not. That's -4. What am I thinking? Yeah, here's the axis. Couldn't quite see the line. So that's not it. What about here? Oh, 1. 0, 1. Okay, cool. So this one does match. 1, 2. 1, 2 matches. 2, 4. 1, 2, 2, 4 matches. So I know that this is C. This is graph C. But then it asks me to write the equation of the horizontal asymptote. So where is my horizontal asymptote? It's right here. And what's the equation of that line? Well, that line happens to be my x-axis. That's where y equals 0. So y equals 0 is my horizontal asymptote. Now, when we're thinking about this, our behaviors are going to be the same as when we were thinking about the parabola. So right here, this -3 is outside of that, so that's going to be a down 3 shift. So you need to find the one that's down 3. Here, it's with the x, okay? So that's like our h in our parabolic. So it's -h, so that means it's going to go forward 3 units, okay? So it's going to like slide into the positive 3 units. This one we have a -a, so that means if it's negative, just like before, that means it's going to flip upside down. And here we have a -x. So what the -x is going to do is it's going to mirror. It's going to mirror around, okay? And then here, this one is going to be negative and mirror. So those will be, I'm going to write that down just as kind of hints to you as you work on these on your own. This is going to be the one that goes down 3. This one's going to be to the right 3. Okay. This one is going to flip upside down, like a strange thing. This one, because the x is negative, it's going to mirror around the x-axis, or I'm sorry, the y-axis. And this one is going to be upside down and mirror. So hopefully that'll give you some ideas of what exactly is going on with all of those. Okay, so go do some productive struggle, battle with it, work with it, and through that process, come to me with any questions you might have. But those are going to be some of those asymptote and transformation knowledge that you're going to need to continue moving forward. Have a good one.